Raaga, an Associate Solutions Architect here at the AWS offices in Texas. Today, I'm going to show you how to troubleshoot and fix failing health checks for application load balancers. Let's get started. The load balancer sends a health check request to each registered target using the specified port, protocol, and ping path. If the health checks exceed unhealthy threshold count consecutive failures, the load balancer takes the target out of service. When the health checks exceed healthy threshold count consecutive successes, then the load balancer puts the target back in service. Let's see how to check the health of your targets on the AWS Management Console. Log into the AWS Management Console, then navigate to the Amazon Elastic Compute Cloud Console. Next, on the navigation pane under Load Balancing, choose Target Groups. Choose the name of the target group to open its details page. On the Targets tab, the Health Status column indicates the status of each target. If the status is any value other than healthy, then the Status Details column contains more information on the reasons for health check failures. Let us now see how to fix some of the common health check failures. Target.ResponseCodeMismatch. This indicates that the application load balancer sent its health check HTTP GET request to the target on the health check port and path and received a response outside the configured healthy response range. In this case, check your load balancer's health check configuration to verify the configured success code. Then, check whether the expected success codes are being returned by your web server and modify the success code value if necessary. Here you can see that the health check protocol is HTTP, the health check port is 80, and the health check ping path is /health. I've set the success code to 200 so that my application responds with a HTTP 200 to be considered healthy. Let's now connect to my target's IP on the configured ping path and check its response code. As we can see, my application is responding with a HTTP 404, and this is the cause of the failing health checks. Let's now change the health check ping path to a path configured on my application, such as a root path, so that it returns the configured success code. When I do this, I see that my target became healthy. Now, let's see how to fix Target.Timeout request timed out errors. When you see this reason code, it means that the application load balancer sent its health check HTTP GET request to the target and didn't receive a response before the health check timeout elapsed. The load balancer sends a health check request to the target as specified in health check interval seconds and expects a response within the health check timeout period known as health check timeout seconds. If the load balancer does not receive a response within this health check timeout period consecutively for the unhealthy threshold count, then the target is marked as unhealthy. There are two main causes for this failure. There's a connectivity issue between the load balancer and the target. The application isn't responding before the health check timeout period. To check the connectivity between the two, make sure that the target and the load balancer allow traffic to and from each other on the health check port and with the health check protocol. Let's take a look at this on the console. In my case, as you can see, the configured health check port is 80 and the protocol is HTTP. Let's see the security group rules that follow the best practices for this configuration. To the left is the load balancer security group, and to the right is the target security group. In the load balancer security group, I'll add an outbound rule to allow traffic to the instance on the health check port. To do this, let's copy the target security group ID and add it here as the destination. The port is 80. Let's save the changes. Next, in the target security group, I'll add an inbound rule to allow traffic from the load balancer on the health check port. Let's copy the load balancer security group ID and add it here as the source. The port is 80. Let's save these changes. Now, the security group rules look good. Verify that the network ACL associated with the subnets for your load balancer nodes allows inbound traffic on the ephemeral ports. Verify that it also allows outbound traffic on the health check port and ephemeral port. Also, confirm that any OS level firewalls on the target allow health check traffic in and out. If you see no issue with connectivity, then check your application logs to determine how long the server takes to respond. If your health check requests take longer than the configured timeout, adjust the health check settings accordingly. The next reason code I'll discuss is Target.FailedHealthhecks. This code indicates that the load balancer received an error while establishing a connection to the target, or that the target response was malformed. To resolve the issue, verify that your application is up and running. Verify that the target is listening for traffic on the health check port. If your targets have multiple interfaces attached, then verify that your application is listening on the correct network interface. Application Load Balancer uses the ELB Security Policy 2016-08 Security Policy for the HTTPS health checks. Make sure that the target supports one or more matching ciphers and a protocol provided by the load balancer in this security policy to establish the TLS handshake. Let me walk you through a few more health check reason codes that you might come across. ELB Initial Health Check. This indicates that the initial health checks are in progress. ELB Registration in progress. This indicates that the target registration is in progress. Target deregistration in progress. This means that the target deregistration is in progress. Target invalid state. This indicates that the target is in stopped state or terminated state. Target IP unusable. This means that the target type is IP and that you are choosing an IP address that is already in use by a load balancer. Target not in use. This indicates that the target group isn't used by any load balancer, or the target is in an availability zone that isn't enabled for its load balancer. Target not registered. This means that the target isn't registered to the target group. So now you know how to troubleshoot and fix failing health checks for application load balancers. Thanks for watching and happy cloud computing from all of us here at AWS.